guys, so one more time. Guys, we said that this was bent geometry, and when you're trying to figure out the geometry of this, we typically just talk about the geometry around each central atom. So just looking around the carbon, if you see you have 1, 2, 3 bonds, remember, double and triple bonds just count as one. We're really just counting how many sigma bonds. And but there are no lone pairs. So 3 things, no lone pairs is, what did you guys say? Trigonal planar. And here's a picture, right? Here's a model of this. And if you just look around this carbon, do you see 1, 2, 3? That is a nice trigonal plane. What are the bond angles there? 120. 120. And then this, of course, has the same. Make sense? Okay. All right. So now let's talk about all our different options. Okay, so Carmen. How many of you guys chose Carmen's answer? She starts out with like dissolves like. And she said the oil would like the oil, the water would like the water, or the C2Cl4 likes the C2L4, the water likes the water, and so therefore it would layer up. Okay? So we definitely have some people liking Carmen. Okay? Now, this is what I want to ask you guys a question. Let's look at the second one, Adele. Adele says, if there's nothing else around, then actually the C2Cl4 would attract to the water. Is that right?
Yes.
Do you guys agree with that statement?
Yes.
Yeah. We talked about this a little bit on Friday. Why? Guys, what is it? Water certainly has, it has London dispersion forces, dipole, and it even has hydrogen bonding, which is the strongest of all. What intermolecular force can this exhibit when attracting something else? It's a nonpolar molecule. What intermolecular force does it have? London dispersion. Now, not within it, it doesn't have London dispersion, it has covalent bonding, but if it interacts with another of the same, it's going to be London dispersion. So here's my question as we think about Adele's statement, right? Can something with London dispersion be attracted to something that is polar if they are the only 2 molecules around? Yes. Because London dispersion, even though it's not wildly polar, there's some polarity to it, right? There's an electron cloud with randomly moving electrons that can, at one instant, have more electrons on one side than the other. We call it an instantaneous dipole. Okay, does that make sense?
Yeah.
Okay, so let's go back to Carmen. Do you guys think that first statement is really true? That oil or C2Cl4 likes C2Cl4 more than water? Think about it deeper in your mind. Is it possible, let me ask it a different way just so we can experiment with it. Is it possible that a C2Cl4 molecule would actually be more attracted to a water than to another C2Cl4?
Yes.
Yeah. Think of it this way, guys. Let me ask you this question. Would a weak magnet be more attracted to another weak magnet or to a strong magnet? Everybody got that right, okay? So if you think of water with its hydrogen bonding being so polar, it's like the strong magnet, and the C2Cl4 that only has London dispersion being the weak magnet, wouldn't C2Cl4, one molecule, actually be more attracted to the water than to itself? Yes. So guys, here's what I think happens. One more question. Would water be more attracted to another water or to the C2Cl4?
No.
To another water. So here's the deal. I really think when we say like dissolves like, we have programmed you very well, okay? Because you guys really hold on to that. But I really think that water molecules are like a click. You guys know about those clicks, right? They're annoying, aren't they? Okay? I really think that water is so busy being attracted to water that it just forgets about the little C2Cl4. If there's nothing else around, you know how people are in a clique. If there's no one else around, then all of a sudden they're your best friend. Then here comes their friends again, and they're like, Might have forget about you, right? Okay, we know what happens, and if you're part of a clique, I want you to just do some self-reflection and see if you need to grow a little bit, okay? But anyway, I really think that water is like that. It's when there's other water around, it's so busy with the water that it just forgets about the other, and so that, by default, forms a layer. So guys, read the very last statement, and that was who? Royce, okay? Read Royce's statement again and see if Royce really nailed it at a very deep level of understanding. Do you guys see how Royce might be the best?
Yeah.
Yeah, good, Lindsay.